Okay, so on week 7 Friday, we've got our midterm exam, and that's a ways away. That's 2 weeks away, but definitely between now and then, you should start practicing. Okay, you've got 2 weeks to start practicing, but I think that's going to be enough time to become a little bit more fluent and a little bit more proficient in getting your, I guess, your Python and your pandas, and even Matplotlib, which we haven't covered yet, or Matplotlib, which we haven't covered yet, but you can start getting proficient in those, okay? The exam is take home, all right? And so you won't even come to class. You'll just stay somewhere, okay? Go to the library, stay at home, find an office, wherever, okay? I mean, if you want to, no, there is a classroom that comes, there's a class that uses it, so we can't, I guess you can come here for the first hour, but then you'll be scrambling for another place. I mean, you can go out anywhere. It's on a Friday, so that courtyard's practically empty. So you just need a place, and it's open internet, open notes. It's just not, you are not allowed to talk or communicate to other people, okay? Like in the classroom, you can't like work together with your friends. I don't have a great way to police that, except I think the time constraints, I'm gonna post the file, you'll have 2 hours. I think the time constraints will kind of make everybody kind of concerned for themselves. So, that said, you don't want to have to go, so you are allowed to go on the internet and say, how do I do this in Python, okay? That's totally allowed. And most likely you'll encounter different documentation, right? I don't expect everyone to have everything memorized. And absolutely, whenever I do stuff, I'm constantly checking Google for like some of the most basic stuff. But at least I have a little bit of a framework, so like when I see the function, I understand how it's supposed to go. And you're only going to gain proficiency if you do some practice, okay? Unfortunately, but fortunately, DataCamp has these things called projects. So you go to DataCamp, and you have full access to the whole thing. I don't know what DataCamp looks like when you log in. This is what it looks like for me. And they have this section down here that says, get real life experience with projects. It's good, okay? You go to Explore Projects Library, and they have a bunch of these things kind of all lined up for you, all right? The green ones are Python, the blue ones are R, okay? And so, I mean, if you want to practice R, you're welcome to, but that's not going to apply for this class. And I would say what you want to do is where it says All Topics, come down here and select Data Manipulation or Data Visualization. I would say these are going to be the 2 topics that are covered most heavily on the midterm exam, okay? So you're going to click something like that. It's going to filter to data manipulation related projects, and you will just, you'll click one of these things, okay? If you hover over these things and it says machine learning, it might be, it might cover stuff that's not necessary, okay? But basically, you're gonna click one of these things, and it's going to open up a Jupyter notebook over here, and it's going to have some guidance over here, okay? And it'll say, you should have at least gone through these classes, Intro to Python and Intermediate Python, which, I think you guys have completed because it was assigned in your homework, and I think almost all of you are doing a really good job with keeping up with the homework. There's maybe like 3 students who are not doing their homework, but everyone else, good job there, okay? But you want to get more practice. And the thing about these projects is that they tell you what you need to do, but unlike the other, unlike the DataCamp modules, you start off with a cell that's kind of empty, okay? And so, so you have to use your own brain to figure out what it is that you need to type, okay? And so this is going to be a good way to practice and start getting these things in. And I think when you first do a project, you're going to realize I'm really slow and I don't remember a lot of these things, okay? So as you work through them, you know, keep a little notebook by your side, jot down a few of these things, and with practice, and I would say try to get, you know, a handful of these in, 3, 4, 5 of these projects in between now and, you know, in the next 2 weeks to gain some proficiency, okay? I've started linking a few of them under week 6. These are completely optional, all right? They're not assigned homeworks, okay? I can't force you guys to do these things, but I think it's worth it, okay? So it's a great resource, but yeah, Data Camp doesn't have the ability for me to assign these as homework assignments, so you just have to do these kind of on your own motivation. But I think it'll be well worth it. You'll at least get comfortable with this. And I don't know if any of you guys are planning on participating in Data Fest later this year in the spring. You know, one thing that you can try to do is force yourself to do Data Fest with Python, okay? Now, why would you want to do something like that, right? Like, you're not even going to be in this class anymore. But, you know, if you want to tell a prospective employer that you're proficient in Python, like, you're going to need to get some practice in, okay? And so force yourself into these kind of uncomfortable situations where you can't just rely on the old methods that you feel comfortable with, okay? Or I don't know, you know, whatever you want to do, right? So those are my suggestions there, okay? There's only so much, you know, just this format of me being up here and talking and going through examples, it's very passive, and you'll benefit more by doing something active. So anyway, I guess we'll get started. So last Friday, we started taking a look at this New York City flights data set, and we did a few things, and we didn't actually finish the bottom few queries. So I thought maybe we would start there, finishing these last few queries, and then we'll work on, I've got some more queries or more commands to run through in the 0503 notebook as well, okay? Have you guys ever had a flipped class? Do you even know what that is, a flipped classroom? I'm toying around with the idea. Not for you guys, it's too late for that. The idea is I would like record videos, assign the students to watch videos at home, and then in class we would do like interactive learning things. And so you'd watch me talking about, I don't know, pandas at home, and then in class I would have exercises and you would write the code yourself. I'm not quite sure how it would end up working, and so I don't know if anybody had any experience with that, and if it was positive or negative. I'm toying around with the idea for, I'm going to be teaching 102A next quarter. I know you guys, I think most of you had me for 102A. Did anyone not have me for 102A? Who did you have?
Professor Shane.
Who? Oh, you had Professor Chang for summer. Yeah. Okay. Very good. Yeah. So anyway, that's that. I don't know. You guys tell me if I'm walking into a bad idea. All right. So okay. So I just reran the first few chunks of code. Basically, what I had done earlier was we reformatted the data, where the times and whatnot came in as integers, okay? And we had to kind of first tell it, okay, it's not integers, it's treat it as text, and then we chopped up the text times into hours and minutes so that we get a date time object, all of this stuff with pandas. So this was all stuff that we did last Friday, and now we can start asking just some questions about, I guess we didn't even need to do any of that stuff, but just ask questions about the airports and the airlines and things like that, right? Okay, so this is all from New York City, and so here you can just specify the column. Let me zoom in a little bit. You can do the data frame's name is flights, and you can do .origin, and that will refer to the column called origin. If you've got a space in the name of the column, then you're going to have to do like the square bracket with the quote. Okay. Origin dot unique, and this will say how many unique values are there, and we've got 3 of them. Okay. EWR, which is Newark, that's in New Jersey, and then LaGuardia and JFK. All right. And so those are kind of the big airports in that service the Metro New York. In LA, we've got LAX, Long Beach, Ontario, and Burbank that service our things. But okay, and so are there other airports in the LA area? I guess there's like municipal ones, like Van Nuys Airport. But anyway, okay, so we got this, and then if you look at how many times these appear in the data set, they're actually relatively close. They got around. This one has 120,000, 111,000, 104,000. So, within 15% of each other, okay? 104,000 to 120,000. So it's not like one of these airports is massively larger than the others, okay? I mean, there is 15,000 more flights or 16,000 more flights to Newark than LaGuardia, but you have that. Okay. Another thing that you could have done, so here I did flights.origin and .value counts. Value counts is it's a super handy method or function. Okay, you should have this in your vocabulary of functions to remember. But you can also use group by. Okay, and so if you think back to R and dplyr, you have the group by where it's going to kind of identify all the rows with this particular thing. So here we're going to say group by origin, and then so all the rows with the same origin will be grouped together. And then I'm just going to pick one of these columns, okay, such as scheduled departure time dot count, okay. And so when I do that, this is what I get. All right, same numbers as before, okay. If I do a group by and I choose, instead of scheduled departure time, I do departure date and time, these numbers will be different, okay? The reason for the difference is that if it's a NaN, a missing value, count is not going to include it, okay? So here you can do group by. And so there's a similarity, but also distinction from how to do summary functions with dplyr, right? So with dplyr, you would take kind of the data frame, you would pipe it using that pipe function into the group by function, and then from there you would do something like a select to select the column, and then you would do a count. Right? You would do a summarize and count, okay? And here we're doing something similar. We're saying take the data frame, run the group by function on it, and then select one of the columns and count the values in the column. So when you do this, it creates this thing, okay? So we have 3 origin airports. We can say, well, okay, how many destination airports are there? And there's a whole lot, right? IAH, MIA, BQN, I don't even know what these things are, right? I have no, here's Burbank, okay? And there's Long Beach, and I don't know where. There's Los Angeles, San Francisco, Dallas, Fort Worth, Boston, Las Vegas. Is this Orlando, MSP? ORD is, I think, Chicago, Atlanta. I don't know. Okay. There's a whole bunch. Okay, 105 unique destinations. And we can do here, I can take destinations, do the value counts, which will do this thing, whoops, this thing up here, okay? And then we can just take the top 10. And when you do the top 10, you can see the most frequent flights. So 17,000 to Chicago, 17,000 to Atlanta, 16,000 to Los Angeles. I'm assuming that's Boston, MCO. Oh, maybe MCO is Orlando. Okay, MCO is Orlando. CLT is Cleveland? I have no idea. What?
Central limit theorem.
Central limit theorem, yeah, okay. Nerd. All right. All right, if you want, so these are just based off of counts, and we can say which month is most busy, and so I'm just going to say, all right, let's take a look at the departure date and time, okay? And so what am I doing here? Flights, departure date and time. So we're selecting the column, and then I didn't do value counts. If I did value counts directly on that, what would I get? It would be like the exact time that was like April 26th, 5:55 in the morning, had 9 departures, okay? Is that even possible? Like 9 airplanes taking off? I don't know how this works, okay? But okay, so that's not gonna work, right? Okay, so by including DT, okay, date time, this opens up some the possibilities to treat the thing as a date object, right? So it's coming off as a series, and there's certain things, like sometimes you want to treat the elements as strings, and so you can do .dt for a date. You can do .str for to treat as strings. So you can always do kind of pandas series dt. All right. So this is the accessor for date-time-like properties of series values. And so this allows you to kind of, this takes a series that we have selected, and it gives you access to basically date-time properties. You can do series string, okay? And this is going to be the accessor function for string methods, okay? So anything that you can apply onto a string, such as like split and whatever, can be done. Okay, so here I'm going to say dt, and this says treat it as a date, and from a date you can then extract the month, okay? And then I can do a value count. So here we get August has 28,000, and October has 28,000, July. So we get May, July, August, and October. That's strange, okay? And then June and September, I don't know, these other months, a little bit less. January and February are the lowest, okay? And then I can take this, all right? So notice, so Python just allows you to just keep chaining these things using dot notation. So I've just taken this thing, which produces this series, okay? This is a series here, right? It's got, what's the breakdown of the series? This column is the values, okay? It's really just one column of values. It's values, and this is the index. So this is the index. And so what I'm gonna do is I'm gonna say, take that series and sort the index. And so here, let me just kind of show you what this does up here. So it sorts the index from 1 through 12. And then from there, I'm gonna say, let's make a plot, okay? And you can just do plot, and you can specify what kind of plot you want to do, and here you go, okay? And so we can see it dips January, February, not very many flights. This might be an artifact of the fact that February only has 28 days as well, okay? And so yeah, I guess that makes sense, right? So I was kind of wondering, why is August, why does it go from 8, 10, and 7, and 5, and it's not including? Okay, that's probably a fact that August August, October, July, and May all have 31 days versus these ones, not March, but April, June, September only have 30 days, okay? So perhaps I should do these divided by, and I would have to do like 31 or 30 or something like that, right? Okay, so we get kind of this pattern here. You could do it by day, all right? And this will tell you that the 15th day of the month has the most flights, okay? And then whereas the 31st has the fewest flights, and that makes sense because only 6 months have 31 days. How many? I don't know how many months, right? Gee. You're gonna have to count on my fingers here. So in English, we have this rhyme, right? A little limerick. It goes like 30 days hath September, April, May, June, November. I don't remember. How does it go?
I don't know.
Do they have?
But there's the knuckle one.
There's the knuckle one. Yeah. January. Okay. I'm just curious if there's like these little rhymes for other languages. No, they just say this is it. Remember, February 28, except on years divisible by 4, but not years divisible by 400. Okay. What time of day is most busy? Okay. So here I'm going to group by, and then we're going to say let's group by the hour, and then let's count them out. Okay. So what do we see? 8 a.m. Lots of flights. Not very many flights at 2 in the morning or 3 in the morning. Okay, that makes sense. Who wants to take off at 3 in the morning? Okay, and this is what we see. Pretty much probably none of these flights. I think these were the actual departure day and time. If I did scheduled departure day and time, you don't even have 2, 3, and 4 in the morning, okay? So the flights that took off at 3 in the morning, something went wrong. And that's why they took off at 3 in the morning. I mean, really, like, who would buy a ticket for a flight at 3 in the morning? It'd have to be heavily discounted or something for you to consider it, right? If we're gonna offer you a cheaper thing, then people will do silly stuff, right? They'll line up for like 4 hours to get a free hamburger when the hamburger costs $5. So you're getting $1.25 per hour of your time. But I don't know, you say free and then you'll get a huge line. Not optimistic. I mean, not optimal, non-optimal use of time. Okay, so anyway, I'm taking a look at this, right? This is the next notebook, same data set, okay? And here, when we take a closer look at some of the properties of our data set, we realize there are some issues here, okay? So anyway, here's just some info, right? We've got a bunch of things, and it tells us what are objects and what are integers and stuff. And this is after, so on Friday, I think last Friday, I talked about converting all of these things into times, and so we did all of these things into convert times, and we appended it to our matrix here. Okay, so here we might want to be curious, like how many flights, or find all the flights that had an arrival delay of 2 or more hours. So we want to know how many flights landed 2 hours later than what they were scheduled, right? So this is when you go to pick up your friend from the airport, this is always annoying when it happens, right? All right, I'm coming at 3 o'clock. You get there at 3 o'clock, they're not there. and it says it's going to arrive at 5. Well, thankfully we have the internet now, and you can just check and you can say, oh, arriving 2 hours late. But prior to that, okay, so when we do this, what I did was I did flights.location, okay, flights.location, and I did flights.arrival delay, and we're going to change the arrival delay to a float, and we're going to say compare that to the number 120. Okay, so we've got the arrival delay. We take this and we say, is this greater than 120? And then when we do that, we get 10,000 rows. Okay. Here's something that we can also do, right? Someone might say, well, what if I did arrival time versus scheduled arrival time, right? So these are some columns I can do. It arrived at 8:30 in the morning. It was scheduled to arrive at 8:19. So that's a delay of 11 minutes. So it's often a good idea to kind of just check to see if these match, right? So I'm going to do arrival date and time minus scheduled arrival date and time. Is that greater than 120 minutes? Okay, so when you do arrival date and time, if you compare like two, you get something known as a time delta. Okay, which is interesting, right? So we understand this as like, okay, that's 11 minutes, right? And it doesn't appear here, but like if it says we often don't think about this, but the computer programmers who designed the language had to think about this, right? So if you see 11, you're like, okay, that was 11 minutes late. And if I did, something bigger, it could have ended up being like 120 minutes late or something like that, right? And so should all time deltas be recorded, like differences in time, be recorded in minutes? Well, that doesn't make sense. If it comes in on one day and it comes in on another day, like you don't want to know that it was like, 1,000 whatever minutes late or something. That's not helpful. So it comes back and it says like, the difference is, this is a little hard to read, but -1 plus 23 and 42 minutes. So that basically means 18 minutes early. Okay, this is the difference between, that's 18 minutes early. So anyway, you can compare this to a time delta of basically 120 minutes or 2 hours, and it will subset this and say, okay, it's true and false. So you get a true-false Boolean vector there, and we'll subset this and we'll ask, okay, how many do we have? And when I do this, I get something drastically different. When I said arrival delay greater than 120 minutes, I get something around 10,000, and here I only got 7,400, okay? So now, in the course of your process, if you see something like this happening, this should be a red flag, and this should tell you, I have done something wrong somewhere. Something is not quite right. Because if everything were correct, these numbers should match. So why am I getting a difference? Any suspects? Any ideas so far? Okay. We will discover. We're going to have to investigate to figure out why there is a mismatch, okay? So what I'm going to do is I'm going to say, all right, let's figure out the flights that have arrival delay column greater than 120. And then over here, I've got B, and this will be the flights where if I take the difference between arrival time and the scheduled arrival time is greater than 120. And in my mind, those things should be the same, but they're not the same. So what's going on, okay? So here's kind of the, this lists off. So what I've done is I've taken that and I said, okay, give me the index, right? And over here, so the index of A has 10,000 elements in it, and the index of B, if I check it, will have 7,474 elements. And so there's a function that you can take basically any kind of list thing and just say, what's the difference between these two, all right? And so I got a difference of close to 3,000, 2,979. And it says, all right, one of the values that's different is row 151, okay? So I'm going to just pull out one of these rows, all right? And let's just try to see what happened as far as the thing, right? So we look at this and it says, okay, it was January 1st, 2013. It was supposed to depart 8:48 in the morning. It departed at 18:35, so 6:30 in the evening. Okay, the departure delay was 853 minutes. Okay, it was supposed to, and it arrived at 10:01 in the morning, whereas it was supposed to arrive at 7:50 in the evening, 1950. Okay, and so the arrival delay is 851. That's what we have. However, what do we have here? In the date, okay, the date is, departure time is indeed January 1st, 8:48, and the scheduled departure time, I'm sorry, the scheduled departure time was 18:35. It was supposed to leave at 6:30, okay, and it was supposed to arrive at 7:50, okay, but what happened? It departed at 8:48, okay? So the thing that happened was it was supposed to leave at 6:30 in the morning, or 6:30 in the evening, but it left the following day at 8:48 in the morning, okay? And so when I coded my commands to turn these things, the departure time, into a date, I made a mistake, okay? This should have been 8:48 the following day, January 2nd, and not 8:48 January 1, okay? And similarly, the arrival date needs to be the following day as well, okay? So back here, when we created our thing, then we said make a date time object out of it. You know, we extracted the time, and then we just took the year, month, and day that was listed in that row, which made sense to me, okay? But it doesn't account for these situations where it was scheduled to depart on one day and it departed its actual departure was the following day, right? So that's what we have, okay? If I think kind of playing around with this, I came across just like another row, okay? But I mean, we could have punched in any of these other entries, okay, and just done some investigation, okay? And here the departure time says 10, okay, which probably should have been read as 00, okay, as in 10 minutes after midnight, okay? But I think what happened is that when you export things as a CSV, it ends up dropping the leading zeros, okay? And so, you know, here's something that you can do is you can run a where, and you can just kind of do a substitution. You can use this where function, and this will substitute values in the vector, okay, where something is true with some particular value, okay? And so here I'm going to just say anywhere where it's a empty quote, okay, replace it with like quote 100, and otherwise, where it's not true, just replace it with a value in A, okay? And it's vectorized, so it kind of goes through, and it's going to replace all of these things accordingly. Okay, so to kind of fix this, I'm making, we're going to take the scheduled departure time and the arrival time, and then I'm going to make use of the column departure delay and arrival delay. I'm going to just have to kind of hope that all of these things are correct, and then so we're going to set the departure date and time to the scheduled departure time plus the departure delay, and the arrival time to the scheduled arrival time plus the arrival delay. Okay, so we're gonna take the data, which we assume to be correct, and we restructure the departure date and arrival date and times using that. So we're going to say take what was scheduled and add the delays to get them. Okay, and so we turn these into time deltas, and then you can add an object plus a time delta and get a new thing. And when you do that, then you can create the thing. Okay, and then and we're going to go through everything. All right. So this should clean things up. And if we end up in a situation where the arrival time is less, so if the scheduled arrival time is less than the scheduled departure time, we've got to add 24 hours to it, right? So if it says, because I guess there's a strong assumption here. What's the assumption here that I'm making? And I think this is true. I think it's a safe assumption, but it might not necessarily be true, is that all the flights are less than 24 hours, okay? And so I can get the correct arrival time by adding 24 hours. So if it takes off at 11 p.m. and it arrives at 10 p.m., then I know that the flight took 23 hours. It has to be 10 p.m. the following day. So we're going to look up any place where the arrival time is earlier than the departure time. And if that's the case, we've got to add 24 hours to the arrival time. Okay, so we'll do that, and I'm going to use NP where. In the same way here, I'm going to use NP where and say, wherever this is true, add 24 hours. Otherwise, just keep the original scheduled arrival time. Okay, and so we're going to do this to the scheduled arrival time and the arrival time. So this is just a bunch of kind of like data handling and cleanup, so that we can process and do our work appropriately, right? So these are some things that, we wouldn't have realized this until we started poking around and getting results that we weren't expecting, okay? So I always recommend doing something like that. Poke around, and if you're getting results that you're not expecting, then check. Okay, so now we can take a look back at that problematic row, all right? And we can see that the scheduled departure time was January 1 at 6:35 in the evening, and the actual departure time was January 2 at 8:48 in the morning, okay? And likewise, the scheduled arrival time and the actual arrival time are reflected accordingly, okay? Have been updated to January 2nd, okay? And here's the one where it said the departure time is 10, but and it goes in correctly as midnight, 10 minutes after midnight. Okay. So we'll go in and check, and now when we do the arrival delay greater than 120 minutes versus arrival time minus scheduled arrival time with a time delta greater than 120 minutes, then our results match, and that's a good. Okay, so then we can kind of proceed forward with kind of our analysis, right? And so now we just kind of have some exercises, and we can just say like, all right, how do we find flights that flew to Houston? Okay, and the Houston airports are IAH and HOU, all right? And so here we can just do basically the .loc locator, and you basically specify the conditions that you want. So I want destination is in IAH and HOU, okay? And we can do this. I want to say there's a new thing now, and it's called query. Let me just look up pandas query, data frame query. So you can just say query where df.b is equal to this. Okay, so let's try this. So I'm going to do flights.dest. I guess it's not any better. IH. I guess it looks exactly the same, but no, that didn't work. Okay, flights.destination is in. Okay. Oh, is in is spelled wrong. Okay. Expression must be a string to be evaluated. I don't think this will work. Lengths must match. So I probably have to do. Okay, this makes it less desirable. We're gonna do flights.dest. Nope. Okay. I don't know how to use query yet. I'm gonna have to mess with it. What am I getting now? Do I have to put quotes around the whole thing? I don't think so. Oh, maybe I do? That seems weird. Okay, I'm breaking something. All right, well, the .loc, this is what I learned, and so that's what I put in the notebook because that's what I'm comfortable with. But I do know that this query function does exist. I just haven't gotten comfortable with it, so I'll have to study up on that. Okay, okay. So flights.loc. All right, if you want to do like those that were operated by any of these, the three big carriers, United, American, and Delta, you can do that. Departed in the summer, right? So a lot of these things, I'm basically just finding the attribute, and I'm just using is in, and I'm saying, okay, 7, 8, and 9. So for July, August, September months, okay? Here you can do arrived more than 2 hours late, but didn't leave late, okay? So here we can say where the arrival delay is greater than 120, but the departure delay was less than 0, less than or equal to 0, right? And we can say, well, how many times did this happen? Okay, and it happened 29 times. I'm not sure what happened on these flights, but the arrival time, it was supposed to arrive at 15:50. It pretty much departed on time, okay, but it came in over 2 hours late. So who knows what happened on these days? Are they the same day? No, January 27th, October 7th in, where was the destination? Oh, it's not listed here. Okay, it's hard to know. Okay, and then just some other things. So one thing about with the NumPy, or not the NumPy, with pandas, when you're doing some kind of a set of multiple conditions, you use the kind of bitwise Boolean connector, the ampersand and the vertical bar for or, ampersand for and vertical bar for or, whereas in traditional Python you use the words and the word or, the literal words a and d and the little word or. Okay, so that's just something you got to remember and keep in mind. Like when you use the and sign, the ampersand, or the vertical bar, and so you can kind of specify these things. So these are flights that took off an hour late but made up over 30 minutes in the flight. Sometimes that happens, right? Like the airplane just like flies as fast as it can, which pretty much all airplanes can fly faster and arrive earlier than what they were scheduled for, but they schedule them the current flights are scheduled in such a way that it's basically you can cruise at a fuel efficient rate, right? It's like driving at 55 miles per hour on the highway, which will be fuel efficient, but you'll get there late. So these people are basically, and pretty much all the flights are scheduled so that they're cruising at the equivalent of 55 miles per hour. And I guess these ones that made up their things, they decided to drive 70 on the highway, which uses more gas, which uses more fuel, but avoids the issues of having delays, which also cost the airlines money. So, all right, here we see. Okay, we're gonna run out of time, but I've got a bunch of these group by operators. Okay. Anyway, you can kind of go through this. I've created a few plots here. So I said group by weekday and count. All right, what day of the week do you think is least busy? Just curious, at the airport. You are wrong, okay? The least busy day is Saturday, okay? Oh, you are surprised because you are students and you are not business people, okay? All right. Pretty much all the, you fly on Saturday because that's convenient for you, but pretty much everyone who works, they fly, they say, I'm going to get paid when I'm going to go flying, and I'm going to go flying on Monday, Tuesday, and Wednesday. And so they fly for business trips, and so Monday through Friday are the busiest days of the week. Okay, Saturday is actually the least busy. Right? It's different being traveling for pleasure versus traveling for business. I bet if there was something that said like which ones let's get rid of everyone who's flying for business. Well, actually, everything's a mix anyway, right? There's no flight that's designated this one's business only flight. Okay. You'd want to go on that one, but okay. So anyway, you can do this. Use group by, and here's just like you can do plot. So the data frame itself that you create. So what did I do here? I said W. This produces a series, and then I just made a data frame out of a series. Okay, and then I renamed the series, the index, to Monday through Sunday, okay, and created the plot accordingly. I would say go through these notes, start working on those projects, okay, and you'll get some good practice in there. Okay, so go on data camp, try to do a couple of projects. I know you've got regular data camp homework on top of everything else, but I strongly encourage you to start practicing with some data camp projects. All right, have a great weekend, you guys.